building an AI-driven Q&A system for security documents with LangChain, GPT, and VectorDB on AWS Serverless. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Introduction: Automating Security Document Management. Managing security documents can be daunting, especially when the volume of data is large and complex. Traditional keyword-based searches often need to catch up, making it difficult to find relevant information quickly. By leveraging AI, particularly natural language processing, NLP, and vector databases, we can create an intelligent Q&A system that simplifies document management and enhances search capabilities. In this podcast, we'll make an AI-powered Q&A system using LangChain, GPT, and VectorDB on AWS Serverless. Solution Overview: Simplifying complex searches. The solution we're building automates and simplifies searching through security documents. By using semantic search with a vector database, we can enable users to find relevant information based on the meaning of their queries rather than relying on exact keyword matches. The system is built on AWS's serverless architecture, ensuring scalability and cost-effectiveness. Step 1. Building the vector database with FICE. Understanding vector databases and semantic similarity. Vector databases store data as high-dimensional vectors, making them ideal for semantic similarity searches. These vectors represent the meaning of documents and queries, allowing for more accurate information retrieval than traditional search methods. Installing necessary libraries and reading documents. First, you must install the necessary libraries to build the vector database. This includes FICE for vector search, OpenAI for generating embeddings, and LangChain for integrating the Q&A logic. Pip install FICE CPU OpenAI LangChain. Once the libraries are installed, read the security documents that must be indexed. These documents will be converted into vector embeddings. Creating the vector database with OpenAI embeddings. Convert the documents into vector format using OpenAI's embeddings. FICE will then index these vectors, allowing fast and efficient similarity searches. Import FICE. From OpenAI.embeddings_utils import get_embedding. Hash example of creating vectors. Documents equals, document 1 content, document 2 content embeddings equals, get_embedding doc for doc in documents. Hash create FICE index. Index equals FICE.index flatel2 len embedding 0, index.add embeddings. Step 2. Develop the Q&A code with LangChain. Implementing chatbot logic with retrieval QA LangChain provides an easy way to integrate your vector database with a Q&A system. Retrieval QA lets you fetch the most relevant documents from the vector database and generate answers using GPT. From LangChain.retrievers import FICE retriever. From LangChain.chains import retrieval QA. Retriever equals FICE retriever index equals index QA_chain equals retrieval QA. Retriever equals retriever. Using prompt templates to optimize responses. To optimize the responses, you can use prompt templates that structure the query passed to GPT. This ensures that the responses are relevant and well-formatted. From LangChain.prompts import prompt template. Template equals prompt template. Input_variables equals question. Template equals given the following question. Question: provide a concise and accurate answer. QA_chain.template equals template. Step 3. Configuring the AWS Lambda function. Installing libraries and using Lambda layers. AWS Lambda is used to host the Q&A code. Since Lambda limits the size of deployment packages, you can use Lambda layers to manage your dependencies. Hash example command to create a Lambda layer. Zip r9 layer.zip python / AWS Lambda publish layer version layer name my layer zip file fuleb : / layer.zip. Managing environment variables and authentication tokens. To keep your API keys and environment variables secure, use AWS Secrets Manager or Lambda's environment variable feature to manage them. Step 4. Setting up the AWS infrastructure. Using EFS, Elastic File System, for database storage. Since FICE requires a persistent file system, use EFS to store your vector database. EFS can be mounted directly to Lambda functions, ensuring your index is always accessible. Configuring VPC, Virtual Private Cloud, and NAT Gateway. Set up a VPC and NAT Gateway to securely connect your Lambda function to the Internet, allowing it to access external APIs like OpenAI. Connecting EFS to Lambda function and uploading the database. Mount the EFS to your Lambda function and upload the vector database files, ensuring they are available during execution. Creating the API gateway and final testing. Use AWS API Gateway to expose your Lambda function as a REST API. This will allow external applications to interact with your Q&A system. AWS API Gateway create REST API name queue and AAPI. Configuring API Gateway for external access. Configure API Gateway with the necessary security settings, such as API keys or OAuth, to control access to your Q&A system. Testing Lambda integration and API with HTTP calls. Finally, test your setup by making HTTP calls to the API Gateway endpoint to ensure everything works as expected. Conclusion: an intelligent Q&A for security documents. Summary of steps and key components. In this podcast, we built an AI-powered Q&A system for security documents using LangChain, GPT, and FICE on AWS Serverless infrastructure. The key components included building a vector database, developing the Q&A logic, configuring AWS Lambda, and setting up the necessary AWS infrastructure. Potential improvements and further applications. Improvements include expanding the vector database to cover more document types or integrating additional AI models for even better accuracy. This solution can also be adapted for other industries that require complex document management and search capabilities. Thank you for listening to our podcast. Please share this podcast, visit our website, and follow our social media links.